1997, as part of the Oregon Plan for Salmon and Watersheds, the Oregon Department of Fish and Wildlife began monitoring migration and survival of salmonid fishes in selected basins. From north to south, these basins include North Scappoose Creek, North Fork Nehalem River, East Fork Trask River, Mill Creek Siletz River, Mill Creek Yaquina River, Cascade Creek, West Fork Smith River, and Winchester Creek. The primary objectives of the Salmonid Life Cycle Monitoring Project are to first estimate the abundance of returning adult salmonids and downstream migrating juvenile salmonids, and second, estimate both marine and freshwater survival rates of coho salmon. Located in the northern Oregon Coast Range, Salmonid life cycle monitoring began in the North Fork Nehalem River Basin in 1998. Approximately 20 miles upstream of the Pacific Ocean and 12 miles upstream of the main stem Nehalem River, the North Fork Nehalem Life Cycle Monitoring Basin contains 48 miles of coho rearing and spawning habitat. Data collection in the basin involves the operation of 2 adult traps, the first of which located at Waterhouse Falls, a partial migration barrier to upstream anadromous migration. The second adult trap is located 4 miles upstream of Waterhouse Falls at Fall Creek Falls, also a partial migration barrier to upstream anadromous migration. Because Waterhouse Falls is a partial migration barrier and not all adults migrating upstream go through the latter, a Mark-Recapture methodology is employed to estimate total wild spawners of all species upstream of the falls.
770.
To accomplish Mark-Recapture objectives, all wild fish are tagged at the Waterhouse Falls adult trap. The ratio of tagged to untagged fish recovered as carcasses on spawning surveys and captured alive at the Fall Creek Falls adult trap is then used to make population estimates for all species. Counts of live fish and reds and biological and tag data from carcasses is recorded in over 70 spawning survey reaches upstream of Waterhouse Falls. The North Fork Nehalem River Basin has annual returns of wild coho salmon, fall Chinook salmon, winter steelhead, and sea-run cutthroat trout. Located 1 mile downstream of Waterhouse Falls, Nehalem Hatchery also releases hatchery coho and winter steelhead into the North Fork Nehalem River Basin. The majority of these fish are captured in a holding pen at the hatchery. However, in most years, a significant number of hatchery fish bypass the hatchery trap and are caught upstream at the life cycle monitoring adult traps throughout the season. Hatchery fish, identified from wild fish by the presence of adipose and other fin clips, are typically euthanized at the traps and donated to the food bank or used for stream enrichment. Not all hatchery fish are caught at the life cycle monitoring adult traps, and in most years, a significant number are observed upstream on the spawning grounds. With strong El Niño conditions present and extremely warm sea surface temperature anomalies in the Pacific Ocean, the 2015 fall adult trapping season on the North Fork Nehalem began with low water levels, barely registering on the gauge of the Waterhouse Falls adult trap. The majority of weather forecasters were in agreement that El Niño would lead to mild and dry conditions persisting into spring 2016. Our adult trapping season officially began on October 1st, with staff removing all trapping gear from storage, loading it up into our work vehicles, and then hauling it up to the adult trapping locations for installation and assembly. And after tightening a few last bolts and opening up the head gates, water began filling the traps and we were fishing for the season. As the first significant rains of the season descended on the North Fork Nehalem, and returning adult salmon began making their way up the river, staff dodged log trucks and drove through stormy conditions to greet them. Heavy rain and wind were typical of these fall coastal storms, bringing much needed water to the river and also large quantities of leaf debris from riparian trees and riverbanks. The aesthetic beauty of fall foliage may be undeniable, but when operating fish traps with grating designed to catch even the smallest jack salmon, those same leaves can be a nightmare as they quickly plug traps and reduce attractant flow for upstream migrating salmon. As is the case every season, staff spent considerable time hauling netful after netful of leaves from the trap in order to keep it clean of debris and fishing optimally for trapping. With the grates clean of leaves and other debris, and a steady turbulent attractant flow down the ladder, it was our hopes that we would reduce the number of fish jumping Waterhouse Falls and attract more fish into the trap to be tagged. Catch at the Waterhouse Falls adult trap was steady early in the season, with few fish pushing higher in the system to the upper trap at Fall Creek Falls. Staff worked efficiently to tag and collect biological data from wild fish as quickly as possible, as fish processing requires water flow into the trap to be reduced for safe handling of fish in the trapping area.
199-200.
After all fish were processed during a trap check, the head gate was cranked back open to get water flowing again through the ladder. This provided attraction flow for new fish to enter the trap, and also allowed wild fish that were already processed to exit the trap volitionally. Biological data were also collected from hatchery fish, but these fish were then euthanized at the traps to reduce the number of hatchery strays on the spawning grounds. Between fish checks, staff ran food-grade hatchery fish up the steps of the trap to an ice-filled tote near the parking area. At a later time, these fish were picked up by a local volunteer associated with the food bank effort. On this day, Laura Swanson, coordinator of this year's food bank effort, excitedly picks up fish from our best haul of the season.
56, yay!
Perfect.
As fall rains became more intense and river level increased, we began making more frequent runs to the Fall Creek Falls adult trap to process fish at that location. Very few wild Chinook or hatchery fish are caught at the Fall Creek Falls adult trap, so most of our time in the fall is spent tagging and passing wild coho. This year was no exception. On peak fish days, which occurred a little less this year than in most, we often found ourselves finishing up the day processing fish at the Waterhouse Falls adult trap at dark.
Female.
The willingness to work a little longer on days when the river is up and the fish are really moving well is very important for a number of reasons. First, these days are typically associated with high debris loads, so keeping the trap clean of debris for a longer time period allows it to fish more effectively, thereby increasing the number of fish tagged.
715.
Second, the more wild fish tagged, the higher the confidence we have in our population estimate at the end of the season. And lastly, peak fish movement typically occurs in the afternoon and into the evening, especially for Chinook.
Nice work, guys.
Covering the traps into the evening on peak fish days can really pay off at the end of the season. By late October, we passed enough wild salmon upstream of the Waterhouse Falls adult trap to begin spawning surveys in the basin. Conducted by floating the mainstem areas and walking the tributary reaches, spawning surveys were completed with the primary goal of finding as many salmon carcasses as possible to determine the percentage of tagged fish. We surveyed the upper main stem above Fall Creek Falls several times during the fall. The 3 reaches in this section were fun to float, as numerous boulder gardens and lots of whitewater had to be navigated to safely get down to the Fall Creek Falls adult trap. However, fish use in these reaches was low, as very few coho were passed to the upper adult trap this year, and few fall chinook make it up this far in the basin. The 7 spawning reaches between our lower and upper adult traps were by far more productive. The start to these surveys requires a river crossing at a campsite near the trap and then a portage around Fall Creek Falls. Although the lower main stem still has its hazards, it tends to be a little mellower than the upper main stem and also has some very productive areas for spawning. Live fish counts allowed us to identify areas of high fish use and to prioritize areas where carcasses were likely to be found.
Untagged wild.
With an above-average fall chinook run this year, we found a good number of chinook carcasses in the lower main stem.
Nice. Big fish.
Steadily making our way down the river while scanning in all directions, our boats filled up fast with carcasses in high fish use areas. When there was no more foot space in the boat, and the pungent and rotten smell of carcasses became too unbearable, it was usually decided it was time to process fish. And then it was back to floating. All of our other spawning surveys in the basin are done by walking, as none of the tributary reaches are big enough to float. More energy is required hiking upstream in the current than floating downstream with the current in a boat, but the real advantage of walking surveys is the ability to easily stop and more thoroughly search for carcasses. Ask yourself now if you saw the big chinook carcass in the wood jam in the previous clip. If not, well, here's where he was hiding. This one could have easily been missed, and yes, this is exactly where we found him too.
No tags in it.
No tags present indicates this big wild chinook jumped Waterhouse Falls and avoided the trap on its way upstream to spawn.
820.
And cutting the tail means we won't double count him when we do this survey again. This season, our tributary surveys produced many wild chinook carcasses, the majority of the basin's wild coho carcasses, and some hatchery fish as well.
Hatchery chinook, it's like female.
Remember those weather predictions previously mentioned earlier of a mild and dry fall and winter? Well, let's just say it was mild, but it definitely was not dry. In mid-November, the first of a number of strong storms battered the coast. Gale-force winds led to power outages around the county, and unrelenting rain led to serious flooding. The North Fort Nehalem River, previously flowing at normal fall flows, quickly turned into a raging torrent of mud and debris. The high water chased anglers from the hatchery and made for unsafe conditions for us to trap adult fish. Water levels in our spawning survey reaches also rose too high for us to safely conduct surveys. When floodwaters receded towards the end of November, we thought we had survived the worst of the fall storms. But what we did not know at the time is that December would be one of the wettest on record, with nearly 3.5 feet of rain falling throughout the month. This would lead to 2 more flood events and continuing high flows through Christmas. The last major storm in December was extremely destructive, as millions of dollars in damage occurred on the northern Oregon coast. The North Fort Nehalem once again changed from a moderate level and a beautiful shade of steelhead green to extremely high and muddy, and then to a raging torrent in the color of chocolate. Over the course of a month and a half, flooding and continually high flows forced us to close the adult traps for an unprecedented 20 days. And on 2 separate occasions, the North Fork Nehalem River crested over top of the Waterhouse Falls adult trap, equating to nearly a 10-foot rise in river level from the start of the season. Keeping spawning surveys on schedule was a challenge, especially in December with high turbid flows persisting throughout the month. When the rivers look like this for most of the winter after it's predicted to be drier than normal, it's hard not to lose a little faith in the weatherman. After battling the elements for the latter half of November and all of December, our 2015 fall adult trapping season wrapped up on January 16th, with the last salmon carcass of the season found on a spawning survey that day. Upon completion of the fall field season, staff entered the last days of fish catch from the adult traps, downloaded the final spawning survey data of the season, and performed one last quality check of all fish data before running population estimates.
White tags 2680, 2681, scale number.
The 2015 wild coho catch at the Waterhouse Falls adult trap was below average, as 545 fish were captured for the season, significantly lower than the project high of 3,034 fish captured in 2014, and well below the project average of 879 fish. Capture efficiency, however, was high, as 61% of the coho run passed through the Waterhouse Falls adult trap, slightly higher than the 10-year average efficiency for coho, and at least partly attributable to efforts cleaning debris from the traps during peak fish days that help maintain optimal flows for passage. High water in late November and all of December likely had a minimal impact on the number of coho tagged, as past data show on average 90% of the coho run passes the Waterhouse Falls adult trap by mid-November. Run timing of wild coho captured at the Waterhouse Falls adult trap in 2015 ranged from October 4th through January 13th, with 73% of the run trapped by October 31st, 93% of the run trapped by November 16th, and only 5 fish captured after December 6th. With the majority of the coho run passing through the Waterhouse Falls adult trap, we were able to make an accurate estimate of spawners in the basin. The 2015 adult wild coho spawner estimate was below average, as 783 fish were estimated to have spawned in the basin upstream of Waterhouse Falls, significantly lower than the project high of nearly 7,000 spawners in 2014, and also significantly lower than the project average of approximately 1,800 spawners. Marine survival for this brood year was low at 3.3%, significantly lower than the project high of 21% in 2014, and about 50% of the project average. Consistent with poor survival, coho were smaller this year at an average size of 615 millimeters. This was 65 millimeters smaller than the 10-year average, and the biggest fish captured in 2015 was 75 millimeters smaller than the 10-year average. Additionally, scale aging showed some adults returned to sizes more typical of jacks, further evidence of poor growth in the ocean. The 2015 hatchery coho catch at the Waterhouse Falls adult trap was also below average, as 365 fish were captured for the season, significantly lower than the project high of 2,029 fish captured in 2014, and well below the project average of 543 fish. Only 147 hatchery coho were donated to the food bank in 2015, well below the program average of 295 fish. A poor return and many fish being of insufficient food quality at the time of capture led to reduced donations. However, this allowed us to stream enrich over 200 hatchery fish, providing an important watershed benefit in addition to the human benefit associated with the food bank effort. After removing all hatchery coho captured at the life cycle monitoring adult traps, the 2015 adult hatchery coho spawner estimate was below average, as 213 fish were estimated to have spawned in the basin upstream of Waterhouse Falls. This was significantly lower than the average of 541 spawners in the 9 years since hatchery fish have no longer been passed at the life cycle monitoring adult traps. Removal of hatchery coho at the life cycle monitoring adult traps cannot be understated. In 2015, this effort helped reduce the hatchery coho stray percentage on the spawning grounds by 63%. Eliminating as many hatchery fish as possible from reaching the spawning grounds is extremely important in the conservation and protection of wild fish. The 2015 wild Chinook catch at the Waterhouse Falls adult trap was above average, as 196 fish were captured for the season, significantly lower than the project high of 349 fish captured in 1999, but higher than the project average of 175 fish. Capture efficiency, however, was low, as only 21% of wild Chinook passed through the Waterhouse Falls adult trap, significantly lower than the 10-year average efficiency of 31%. Extra time and effort spent cleaning the trap and fishing more effectively during the season does increase the number of Chinook tagged, but the majority of Chinook still jump Waterhouse Falls in most years. High fall flows and trap closures in 2015 further reduced this efficiency. Run timing of wild Chinook captured at the Waterhouse Falls adult trap in 2015 ranged from October 10th through December 6th, with 66% of the run trapped by October 31st, 89% of the run trapped by November 16th, and only 11 fish captured in December. The 2015 adult wild Chinook spawner estimate was above average, as 895 fish were estimated to have spawned in the basin upstream of Waterhouse Falls, lower than the 2014 estimate of 1,002 spawners, but significantly higher than the project average of 584 spawners. Unfortunately, low trap efficiency reduced our confidence in this estimate. The size of Chinook captured at Waterhouse Falls in 2015 was slightly below average at 790 millimeters. This was 14 millimeters smaller than the 10-year average, and the biggest fish captured in 2015 was 57 millimeters smaller than the 10-year average. However, low efficiency at Waterhouse Falls may have biased size of fish captured. As the life cycle monitoring project transitions into trapping steelhead at the adult traps, conducting steelhead Mark-Recapture and red surveys throughout the basin, and installing and then fishing screw traps to monitor juvenile outmigration in spring, it is hard not to reflect on the crazy fall field season of 2015. A season when consistently high water and flooding causes even more problems than usual, flushing newly installed water temperature loggers and a water level monitor out of several survey reaches, never to be seen again, damaging anchor bolts needed for installment of screw trap winches, and destroying a platform used for juvenile fish processing in spring, washing a gravel walkway from the Waterhouse Falls adult trap twice, forcing us to first refill the area with countless buckets of gravel, but then to ultimately concrete this space after a second flood washed all of the gravel away, and requiring us to close the adult traps for a record number of days, and continually affecting our ability to keep spawning surveys on schedule. To top that all off, a monster December storm even kept some crew members stuck at home for a day, with flooding and landslides blocking routes to work in all directions. The fish gave us a few surprises as well. 1 pink salmon, 2 sockeye salmon, and 4 chum salmon were trapped this past fall. The first time all 3 species have strayed into the basin in the same year and been caught at the life cycle monitoring adult traps. Coho were few and far between. 1 year after the 2014 project record, when in 1 day alone we captured more coho at the adult traps than in the basin for the entire 2015 return year. Returning coho were smaller than average as well, with scales confirming that some very small fish appearing to be jacks were actually adults that stayed in the ocean for 2 years but grew poorly. And the wily Chinook, a fish that I can relate to, evaded capture at the traps even more than usual, as many fish use high flows and trap closures to easily reach spawning grounds without being handled. But surprises and battling the elements is all part of Salmonid life cycle monitoring on the northern Oregon coast, where the only thing you can expect from 1 year to the next is the unexpected. Although you do know you will work in the rain, a lot, the fish will eventually arrive at the traps, and there will be some long days and nights ahead of you, requiring you to be flexible with your schedule so you can work when the rivers rise and the fish move upstream. For the entirety of the field season, you will rely on weather predictions and forecasts to plan your days and weeks, hoping that information gathered from forecasters is accurate enough to prepare you for how the river will be affected by a rain event, and the number of fish to expect at the adult traps, or whether it is safe to fish a screw trap or feasible to conduct a spawning survey. Over the rest of this year and into the foreseeable future, data from the North Fork Nehalem Life Cycle Monitoring Project will be used to help answer some important questions, such as how many juvenile coho survived the drought conditions and warm water temperatures during spring and summer 2015, and then the big floods during fall and winter later that year to smolt in 2016. An interesting question considering coho smolt production in 2016 is from Project High Abundance of approximately 9,000 coho spawners. And how successful were returning wild coho and Chinook spawners in the North Fork Nehalem River Basin during fall 2015, considering numerous high water events and several extreme floods occurred after many fish had completed spawning? Will there still be significant fry production in 2016, or will juvenile estimates indicate flooding had a negative impact on spawning? And how many wild salmon will return to the North Fork Nehalem River Basin over the next few years, with sea surface temperatures and upwelling indices in the Pacific Ocean varying tremendously in recent years? The following map shows sea surface temperature anomalies in the Pacific Ocean beginning in January 2013, with blue shading indicating cooler than average water temperatures, or environmental conditions good for salmon growth and survival, and yellow, orange, and red indicating warmer than average water temperatures, conditions unfavorable for salmon. Focusing on the waters off of the Pacific Northwest, and using coho life history as an example, you can see that sea surface temperature anomalies, shown in this monthly animation, were favorable for outmigrating coho smolts in spring 2013, and despite the movement of warm water close to the Oregon coast by midsummer, significant upwelling and high abundance of zooplankton in cooler nearshore waters ultimately translated into a large adult coho return in fall 2014. However, warm sea surface temperatures had pushed into coastal waters by spring 2014. Combined with minimal upwelling, this made for unfavorable conditions for outmigrating coho smolts, and then translated into a poor adult coho return in fall 2015. A similar outcome is likely for adult coho returning in fall 2016, as very warm sea surface temperatures continued to blanket most of the Pacific Ocean during spring 2015, and then became even more pronounced later that year as a strong El Niño event developed along the equator. Poor ocean conditions in 2014 and 2015 will also likely have a negative impact on adult Chinook returns in upcoming years. And finally, will the ocean cool and become more productive in time for smolts outmigrating in 2016? Current data do show El Niño weakening and sea surface temperature cooling in the Pacific Ocean, but will cool temperatures and sufficient upwelling reach coastal waters in time to benefit smolts outmigrating during spring? Check back in with us in several months to start finding out the answers to some of these important questions. North Oregon Coast Life Cycle Monitoring staff including Aaron Truesdale, Crew Leader, North Fork Nehalem; Wes Burton, Experimental Biology Aide, North Fork Nehalem; Sean Brady, Experimental Biology Aide, North Fork Nehalem; Jennifer King, Experimental Biology Aide, East Fork Trask; Alec Underwood, Experimental Biology Aide, East Fork Trask; and myself, Derek Wiley, Assistant Project Leader, North Oregon Coast, would like to thank you for taking time out of your day to allow us to tell you about our project. And rest assured, next October when the wind is howling and the rain is blowing sideways, you know where we will be, cleaning leaves and other debris from the adult traps, and waiting for our fish to swim up the ladders.